So first of all, thanks everyone for joining. Obviously, the speakers and all of you guys listening in. We're doing this space because Celestia is, very interested in pursuing sort of what the next thing is and trying to understand how the space is evolving. And I think one of the most interesting new topics to explore is MEV in the modular stack. And so we're really excited to kind of have this conversation, and hopefully, it doesn't just end here, but keeps going. And there's more kind of ongoing conversations that get sparked from this. I also want to say that the modular category is still so early that a lot of these things are changing, by the month. And so, like, if we had this space a month previously, we probably would have had a lot of different answers, and it'll probably change significantly a month from now too. So, with that preamble finished, I first want to turn the stage over to the speakers. I'd love for you guys to introduce yourselves and your projects. So why don't we start with you, Elijah?
Yeah, sure. So I'm Elijah. I work on application-specific infrastructure, mostly decentralized finance at Duality. We're currently building a next-gen DEX with a focus on how can we recapture MEV and return it back to liquidity providers because we sort of see this as a major problem. If you've seen a lot of the recent news and analysis on Uniswap LPs and impermanent loss versus rebalancing, all these different ideas, we sort of see this as like a critical problem to scaling DEXs. So that's been a major focus. I do a lot of research, engineering, and occasionally help out with operations. But my focus is very heavily into understanding the dynamics of MEV, especially in the context of application-specific infrastructure. And we've been thinking a lot as well about Celestia and how Celestia fits into the picture there. So excited to share some thoughts.
Awesome, thank you. So you guys are trying to make sure that LPs don't get wrecked, which they seem to. All right, Josh, why don't you give us a background on Astria?
All right, hi, I'm Josh. I'm the CEO and founder of Astria. We're building the shared sequencer network. And so kind of, I guess, how MEV kind of comes into that is just like sequencing in general, just kind of the layer where MEV gets extracted, like fundamentally, right? MEV is kind of, at least in my view, this value that can be extracted based on kind of contextual ordering of transactions, where a more naive, transaction pricing mechanism would just assume that like every transaction is like equivalently valuable relative to kind of resource consumption. And MEV is, kind of changing that dynamic. We're saying like, yeah, one transaction is worth more than another transaction if they're ordered in a different way relative to each other. And so when we're thinking about providing shared sequencing for multiple kind of roll-ups in this modular ecosystem, we need to be thinking ahead of, what are the implications of MEV? How are we designing that into our system? And what impact is that going to have on, adoption of our shared sequencer for kind of downstream chains?
Thank you, Barry. Let's hear about Skip.
Yeah, I am one of the co-founders of Skip. We build MEV infrastructure for sovereign app chains and rollups. We build two kinds of solutions. One is out of protocol off-chain systems that help intelligently build blocks on behalf of these rollups in these chains so that they can extract as much healthy MEV as possible and prevent the kinds of harmful MEV that they want to avoid, like front running and sandwich attacks. And they can redirect that revenue back to the stakeholders in their chain that they believe as a community deserve it or need it or should have it. And the second kind is in protocol solutions that do similar things around trying to use the application blockchain stack to give validators superpowers to build their own blocks in a way that can be decentralized and integrated into the protocol. So the protocol has more native control over what MEV can and can't support, even without any kind of off-chain actor. We're on a bunch of different chains right now throughout Cosmos: Juno, Terra2, Evmos, Comdex, Injective, and are launching on a handful of others later this month, and excited to spend more time in the Celestia ecosystem and the rollup ecosystem.
Amazing. Yeah, we have a great representation of different people thinking about MEV from different angles, from AMMs and DEXs to sequencers to sovereign MEV in the Cosmos ecosystem, and truly we're blessed to have these guests here today because they're some of the I would say foremost thinkers on these like evolving space of MEV, especially this cutting edge of modular MEV. So with this backgrounds finished, I want to start with we need to sort of lay the foundation for the rest of the conversation about, what is the landscape of MEV today? What are modular blockchains? And how do modular blockchains change the landscape of MEV, or how do we see them, sort of the MEV landscape evolving due to this new sort of architecture for blockchains? So I don't know if anyone wants to sort of take a stab at that first. But I'll open the floor for you guys to jump in and sort of help lay the background for the whole topic.
Yeah, that's super helpful, Nick. I'm probably, out of Elijah and Josh, the least qualified to try to define the modular stack for people, but I can start by trying to talk about sort of like what is MEV actually mean a little bit, just so people have some context, because I find oftentimes like we throw these terms around and nobody really knows what we're talking about, and MEV is one of those words that people use to refer to a million different things. But at the highest level, like, we're talking about the process by which blocks get built, right? There is the way blockchains and rollups work is you have users who sign their transactions that contain some information about what they're trying to do, and they sign them and they broadcast them into the network. And sometime later, those transactions all get hoovered up and combined into a block that gets posted onto the network. And MEV is all about that sort of dark space in between, which is not governed by the protocol, and which can exist in a lot of different ways, and looks very different for an L1 or a rollup or an L3. But it has really meaningful financial consequences for all of the users of the chain, like where transactions are ordered, what transactions are included or aren't included. Obviously, it has consequences for censorship, but it also has consequences for how much money individual traders can make or lose, and whether LPs are able to be profitable or not, and those kinds of things. And so, when we're talking about MEV systems, we're really talking about systems that are like the fabric between like order flow on chain, so those transactions and block space, and how we combine those things into blocks.
Wonderful.
You're great. So Barry kind of giving us a great, I think, overview of what MEV is, and I guess I can give an overview of kind of what we mean when we talk about like the modular stack here, or like the the modular ecosystem. So if we think about like a monolithic blockchain, and then we think about like Barry's explanation of MEV in that context, right? There is some leader selection mechanism, right? So it's whether it's like Ethereum's kind of proof of stake system, or something like Tendermint. There's some mechanism by which like a block proposer is chosen, and then that block proposer generally in these systems has call it like a monopoly on the ordering of transactions within that block. And generally how we see this in, say, like Flashbot's land, like on Ethereum, they will bid out the rights essentially for who wants to pay the most to order blocks in a certain way that is presumably profitable for the people kind of placing those bids. In the modular ecosystem, we move away from this single layered monolithic chain where now we have multiple chains, and therefore there are multiple blocks being produced. So, using kind of a live example here, right, we'll look at like Optimism or Arbitrum. And in those cases, both systems have centralized sequencers. So there's really one party producing the blocks for the rollup. And I think Arbitrum's example from their white paper is like a little easier to kind of reason about. And so they have this sequencer, and transactions go into kind of this one point. So, as Barry mentioned, right, there's not this necessarily like mempool that is sharing around these transactions that then are kind of out in the open for people to decide how they want to order them. There's just this single party that receives the transactions, and then it, at its own discretion, decides how to order every single block. But then the next step that kind of makes this modular, right, is that it chooses to assemble this block and write it down to another chain that it uses for data availability. And so there's a lot of debate in roll-up spaces around definitions of finality, and I'm not sure finality is even the right word, but that's a digression. But generally, about what kind of guarantees you get from when the transaction is safe to be trusted based on whatever mechanisms, whether they're bridging or just for kind of user applications. But that's usually dependent on this bundle of transactions, this block being written in some kind of batch of one or more blocks down to the data availability layer. Whereas in Optimism's case, they're using Ethereum. In a sovereign rollup, they would be using Celestia. And so there's a question of kind of this finality. And I think the kind of question that comes up here is, when you submit a block to a layer below, again, that has to kind of go into the mempool of that data availability layer below you. And there's this kind of open question of, are there implications of MEV based on the block proposer on that layer below you, which is going to be Tendermint based in Celestia's case, and whether or not they want to accept the batch of the transactions from the rollup above you, whether they would censor that, whether you need to pay a bid to get that included sooner rather than later, and all the kind of standard MEV questions about that. And the thing that's kind of upstream from that is the question of finality of the transaction on the rollup layer, and if that is dependent on the layer below it, then there's at least some kind of value that could potentially be, like in MEV, right? Like there's a value for you getting that transaction posted on the DA layer, and maybe there's a mechanism by which the DA layer or the block proposer on it may try to extract that value through, some kind of MEV auction mechanism.
Yeah, all interesting points. I think that's one thing that I haven't gone so deep into, but is a really great point, which is that finality and the extra gadgets you can use in finality. What role does that play in MEV? I think of MEV in a little bit of a simpler way. Obviously, it's not a simple topic to reason about always, but the definition I would give that has been most useful for me is someone always wants to be first, and everyone wants to be included, right? And MEV is just the value that you can get from how you order transactions, and taking people's payments to for how much they value being at at a certain point in that order, and also just taking people's value for just being included in the first place. So MEV is just about ordering inclusion. And I think what excites me about modular MEV, which I think Josh actually brought up a really interesting point about the finality piece. I actually think most of modular MEV is the same tricks as monolithic MEV, just in a slightly different disguise. And so I think modular MEV is just going to boil down to the same things, which is how much does someone want to pay to be first, and how much does someone want to pay to be included. And so I think there's going to be some interesting there's some interesting applications of implications with the sequencing layer. But yeah, I think that's I think where how I've been thinking about it.
So to summarize, MEV is this value that can be sort of extracted or created by imposing a certain ordering of transactions in a block. And in the modular stack is kind of now, instead of having one single mempool, one single blockchain, one block, you kind of have multiple blockchains kind of running on top of each other. And so you have in different layers, so the data availability layer at the bottom, you may have a settlement layer and then an execution layer. You may also have sort of a shared sequencer network within that, which we'll definitely dive into more deeply. But to me, to kind of summarize, I like Barry's mental model of there's a user sending a transaction, there's this black box, and then it gets included in the protocol in a block. And that what happens in that sort of in-between space is MEV. And in a modular stack, that space kind of gets stretched out, or there's more steps in it, because you might submit your transaction to the execution layer, and the sequencer of that layer might put it into their block, but then that execution layer block has to go, for example, to the settlement layer and be ordered there, and then finally to the DA layer. So there's just a lot more, I guess, steps and room for different types of ordering at the end of the day, is maybe potentially one way to think about it.
I think that's a great way to put it. It's like when you have a monolithic chain, like the process from. Sorry, I'm just going to stop talking. There's some kind of announcement going on.
Keep going. It's fine.
Oh. No, I guess expanding on what you said, and I guess I'll try to summarize it in like my words, right? Like, Nick, I think your summary was good in that, if we think about an inclusion in ordering, right? Like, for a user to get a transaction to, I would say, like the level of finality that they want or is like good enough for them, if we think about this in like a general payments thing, right? Like, how final does your transaction have to be for the goods you are presumably transacting for to kind of be given to you? In a monolithic stack, right, there's just the one block. Once it's included in that block, you're like done. But in a modular stack, you think, okay, it has to go through the rollup, and then presumably the rollup has to also get the transaction included in the block for the DA layer, and that is kind of the finality. So you add this extra hop in the middle, and the question is, what can occur at that hop that obviously can't happen in a monolithic stack where that hop does not exist.
Great. That segues really well into, I want to dive a little bit deeper into this and pose the question of, where do we think that MEV will be captured in the modular stack? Will it be at the data availability layer, at the settlement layer, the execution layer, or will it be, this shared sequencer layer that captures it? And should we try to design the modular stack in a way that a certain layers, like MEV doesn't like leak down to, or MEV gets captured at a particular layer? Like, is it desirable to design the modular stack in a way that like is more intentional about directing where MEV goes?
Yeah, great questions. I think like the first question, which is like, where will MEV accrue in the modular stack, is like one that will largely depend on like the norms and culture around validators. I think like this is a point that like I've heard Barry talk a lot about, and he's convinced me of this, which is that like while there's these like formal ways we can define MEV and show how they can be captured, at the end of the day, right? These there's like a social layer below it that has some sort of that has some sort of way that they want to govern their application, right? There's like this set of validators who at the end of the day are coming to consensus on like a lot of these norms, and that's like seen a lot in like the sovereign world with app chains. That said, if you look in the direction of like Ethereum, it's they've sort of taken this approach that like revenue will be maxed out eventually, and so we might as well try to like accelerate the process. And so like everyone's sort of like fighting for themselves, and everyone should just try to maximize revenue by like running these like combinatorial auctions for block space. So I think like there's been a spectrum of ways that communities have treated MEV. You've seen like app chains which have basically banned sandwiching and like threatened with social slashing. But you've also seen generalized smart contract platforms do something very different, which is almost like encourage the capture of MEV. To accelerate, to sort of push people to think more clever about mechanism design. So I think it'll largely depend on like what sort of culture and norms exist, and sort of like at that level. I also think like if you don't want to leave it up to like what norms develop or what culture will sort of surround the validator side of like a modular ecosystem. It becomes clear it's definitely desirable to design systems to try to be proactive about taking a stance on it, either in the form of like wanting to make it more efficient to be captured for validators and or accrue to the application level. I feel very strongly it should probably accrue to the application level and users specifically. So I think there's like a bunch of different directions to go and do that, and we can get more into that. I don't know if now's the time for that or later, but those are sort of my high level thoughts there.
I can give kind of an opinion that's like less on kind of the where you put the value, and what I mean that is like whether you're giving it back to the validators, whether you're giving back to the application developers, or the users, and more so thinking about it in kind of like an architectural capacity. and thinking about, what are the kind of negative externalities potentially of MEV. And so, prior to Flashbots, right, I think a lot of people were familiar with the idea of like a priority gas auction, where, the best way to kind of get this probabilistic likelihood of you getting to close an arbitrage or whatever was just spamming the network. And it's very obvious that like it's undesirable for everyone else who's not one of these, MEV searchers or whatever trying to close this arb, who have some presumed expected profit if they land a transaction. If you're just some normal person wanting to trade or do whatever kind of functionality on the chain, then you're obviously bothered by this kind of noisy neighbor who is, dramatically increasing the gas prices. So there's this negative externality that I think when we think about the opinionated question of like, where do we want MEV to go? You can think about it, where do we want the value of MEV to go? But I can also think about it like, where do we want the activity through which MEV is extracted? So this kind of, peer-to-peer or kind of transactional activity to occur. And my opinion is essentially that like, at a bare minimum, we want to make sure that the extraction of MEV is done in an efficient manner such that it is not kind of polluting the chain for users who may not be, particularly interested in kind of participating in whatever kind of arbitrage game is happening. Yeah, so I guess what I was saying, right, is like in the architectural structure of like MEV extraction, so less so on kind of the social question of like where, who deserves the MEV, and more so of like the negative externalities of the MEV and what defines kind of where the MEV can be extracted is this question of like, what is the canonical chain? And that to some degree defines kind of things around the MEV extraction. So in Ethereum, right, your canonical chain is usually defined by an on-chain smart contract bridge, right? And that has some rule in it of like, this is the sequencer that is allowed to submit the transactions into this, call it like an inbox or whatever. Whereas in a sovereign rollup, it runs something much more similar to like an L1, where you have some rule that is kind of defined by essentially like the software, right? And like the peer-to-peer network that says, this is the valid piece of software. And if you run the software, you will connect to like peers in the network, and those peers will all decide on, a similar like leader selection mechanism. And obviously that like kind of who gets to produce the blocks and who has kind of what kind of monopoly on block production or whatever other mechanism you use will define the structural system of like how MEV can be extracted. And so I think that's one of the big things to kind of think about, because there's a lot of different ways you could design this. I'll just throw out the kind of like naive way you could think about structuring this kind of, rule of what the canonical chain is in like a Celestia thing. That's not something I'm going to kind of like encourage people to do, but it's kind of the simplest possible way that would give an example of how we could push MEV down to the data availability layer, and kind of some of the costs or implications of it is just say, if you say we have some roll up that is, serialized data like such, and we will say the correct chain of this rollup is whoever lands the first block that looks like, a given structure on, top of block within Celestia. And then you just kind of race, right? And you say whoever lands the first block in Celestia gets to decide what the canonical chain is. And you can kind of easily see how that would create a system where the game for deciding, what MEV is kind of extracted on the rollup is defined by an actual MEV game downstream of the rollup on top of Celestia, because people would obviously, first play a priority gas auction on Celestia to say like, okay, I'm going to like spam Celestia in the hopes that like my highest bid will land kind of top of block. And then presumably you would see, some kind of mechanism similar to like skips, right? Where you say, okay, I'm going to pay a bid in some kind of coordinated auction mechanism to say, I will pay, X much for a top of block auction, and you will pay based on what you think you can extract in the rollup. And so I think the design space here is very, very broad, but that's kind of a simple, naive design that would push it down to the DA layer.
One alternative perspective, or maybe this is somewhat aligned with what Elijah said, is like, when I think about where MEV should accrue, in practice, it's often driven by like, these relationships of like power that exist either between individual actors, like the proposer, for example, in the monolithic case, or in the modular stack, increasingly between like the individual actors of the different protocols. So like the proposer of the DA layer versus either the proposer of the shared sequencer or like the validator set of the shared sequencer. And that's like usually what dictates that plus culture and norms. So like what you see in Cosmos, for example, is that many of these app chains, like all of the ones that we work with, are electing to, as the validator set, not extract MEV related to front running and sandwiching, and instead focus on healthy MEV, to Elijah's point about culture, which I think is really interesting because we talked to a bunch of Ethereum folks before building that into our block builder as an option, and they were like, oh, no one's going to use that, no one's going to want that. And like every single validator we work with, barring maybe one or two, has explicitly asked for it. Every protocol we've worked with has explicitly asked for it. So I think like culture and norms do have a role to play. But when I think about like where MEV should accrue, like I think you can take like an ecosystem wide or like a crypto wide perspective, which is, in the long run, we probably want these systems to provide just better UX for people who are actually trading on the chains and are actually like using the technology that we're building. And I think better UX can come in a few different forms. Like, for example, for a DEX, form of better UX is you get better execution price, right? That's why like the front running and sandwiching doesn't matter, or matters, because it makes your execution price worse. So you want to like design your MEV systems to try to give your users better UX from a price perspective, but also like maybe better UX from the perspective of just how easy it is to interact with the chain. How predictable is their experience, right? Like you don't want a system, to Josh's point, where one of the externalities is that like when your shared sequencer posts your transaction to the DA layer for its like finalization, the DA layer's validator set is incentivized to censor you. That's like a bad UX. If you like submit a transaction to some rollup and then you check back 5 minutes later and you're like, oh, what? Like it got accepted by the rollup. Like, why did this never happen? And I think MEV is like actually a pretty powerful force for trying to design systems that have better UX. And I think that's going to be good for crypto overall. Like that's one reason that I'm personally excited about Duality, is that like they're taking this as a first principle of the design and saying, and the chains we work with in Cosmos are the same. They're saying we're going to give MEV back to users and to stakers, and that's going to be part of our competitive advantage. And I think that's a really cool pattern. I think you're going to see that play out more with rollups, and hopefully you're going to see the modular stack like exploit this design space in a way that like ultimately uses MEV as a tool to better off crypto users.
Nice. Yeah, to summarize, it sounds like the design space is really wide, and depending on how, like the choices that are made, MEV can kind of accrue in a lot of different ways. But so it sounds like we're all kind of in agreement that MEV is worst when it has causes negative externalities for users and like on the user experience. And so as long as we should try to design the system in a way where it doesn't impact users, and hopefully even through things like sovereign MEV, it can actually be like beneficial to users, or at least net neutral rather than like extractive. But one thing that kind of popped into my mind as you guys were kind of discussing this was, does MEV kind of threaten the original value prop of modular blockchains? In that kind of one of the selling points is that, okay, we have these discrete like separate protocols and nodes doing like separate things and specializing in different functions across the stack, and they kind of don't have to know about each other and what's happening at each layer. And that way we're able to build this really efficient system. But MEV might create this incentive, for example, for someone to literally run like a node that knows about everything, every layer of the stack. It's like a data availability layer. It's also running at the sequencer layer. It's also running the execution layer, etc. And that way, it's able to capture the most MEV more than anyone else. Like, is that a threat to modular blockchains? Is that inevitable? What do you see?
Yeah, so I see actually like a lot of analogs to how we see like the Ethereum stack of like proposer builder separation and what they call like the MEV supply chain, right? Where theoretically, right, there is this idea that if you are a let's assume like a sovereign rollup case, if you are a block proposer or a validator on Celestia, and you are also a validator on a rollup on top of Celestia, then it is like profitable for you to control both of those things, and therefore when you have the turn as validator on Celestia, you'll just like censor everyone that is not your validator for the rollup above you, and that presumably gives you kind of like more control across the whole stack. And I think there's like legitimacy to kind of like the concerns there, but also what we actually see is, and this is what we've seen in kind of like different discussions across like Cosmos ecosystems and like atomic, cross-chain stuff, like just the overlapping of these things. A lot of it's dependent on kind of the size of the set of, I'll say, like block producers, right? Like if there's like 100 people or 150 people or whatever, like how often do you actually get an overlap between those things? And that overlap will determine how valuable that kind of stacked control is. Whereas I think the reality is, like, if you get to like a relatively small set, the overlaps become rare enough that you're kind of incentivized to say, like, well, I want to get like whatever like the fair market price is for my control of like block proposal at whatever layer I'm at, and therefore I'm just going to kind of sell that off. And it would have to be kind of a very, very large reward in one individual kind of block during that overlap period for that to be kind of the outsized value where that's like kind of your focus. I think there's like these second order and kind of like iterative games concerns over like, if you get a reward by controlling more parts of the stack, then you will acquire more capital, and that capital will allow you to acquire more stake and so on and so forth until you control a really large amount of the network. But I don't think these are concerns we've really seen, and we've seen kind of the economic specialization that fundamentally like modular stacks encourage, where you say, well, someone will actually just go be a searcher over here and they will optimize being a searcher. And then someone else who is like a block proposer will say, like, actually, it's not in my interest to also be a searcher. I'll just kind of bid that out. I'd love to hear from Barry, who has a lot more experience kind of, interacting with searchers and block proposers and validators kind of on the ground and understanding kind of the perspectives they're having in this. Are they thinking about verticalization, or are they all kind of comfortable with, the supply chain as it's split and kind of the individual pieces of that they return to themselves?
Yeah. So in general, I think a good way of thinking about this is people are always in crypto especially, but everywhere, like people are always like in competition with one another. And a lot of times in MEV, that competition leads you to want to verticalize across different parts of this supply chain. So validators want to become builders, or searchers want to become builders and want to build order flow solutions for wallets so they can move across different parts of the stack. I think a lot of validators, so just like speaking specifically to my experiences, most validators that we work with, they see themselves not in competition to like extract as much MEV as possible, but in competition to be seen as like the most aligned with their host protocols. Because if they have like, there's a very clear and present notion of reputation in Cosmos, and the community has the ability to both, through the individual actions of a delegate by staking, or through like social slashing or like foundation grants, like reward and punish people, validators, for different kinds of actions there. And so because this competition is based around like how good of a steward am I seen as, like it leads less towards verticalization and more towards supporting like recapture for users or recapture for stakers, because they're really just trying to get as much stake as possible. So like validators in Cosmos frequently advertise that they're using Skip. Like they'll change the name of their validators as it appears on chain to say like, oh, like my validator, and then in parentheses 100% of MEV returned to stakers. And that's because their view is, they can make more money by getting more stake, as opposed to make more money by just trying to extract. And that if they just try to extract, they'll be seen as worse stewards, which will be harmful for them. For searchers, I think it's interesting, like the line between searcher and builder blurry in Ethereum. Like the thing that I've always said is like a searcher is really just like a builder that has less order flow and like better algorithms, and a builder is just a searcher that's focusing on order flow. And I think like increasingly you're going to see those roles look more and more similar in Ethereum, which has like the most mature ecosystem around this by far.
I'd love to kind of double down on the thing you mentioned about kind of the validators being good stewards, because I think it's an interesting concept. And I think, historically we saw, discussions in Ethereum. I'm going to get like the dates wrong, but somewhere around like circa like 2018, 2019, with the miners, there were discussions of like, oh, should we be kind of like extracting things? Is there value here? When kind of, I think it was like Balancer or whatever was the first kind of opportunity showing up where the miners could say, hey, we could reorg things, not reorg, but like reorder transactions in a way that is like more profitable for us. And maybe that returns us more money and such rate, like revenue is like compounding, whether it's proof of stake or proof of work. But what, the same argument they used was like us as like a mining pool would be viewed as like bad actors by the protocol. And therefore we will not do it. But like eventually this kind of like floodgate broke, right? Like eventually someone just said like, screw it, like we're going to go be like maximally extractive and we will return like the highest yield because we are maximizing our kind of monetary returns. And people that don't believe that is kind of incentive aligned or whatever will not, participate in our mining pool. But people who are just kind of like ruthlessly maximizing profit will say, okay, fine, we just want like the higher yield. So I think there was this existing historical situation in Ethereum, and kind of the best discussion of this I've seen, I think, was like a chopping block podcast on like MEV, maybe, I don't know, like 6 weeks ago or something. But it didn't like hold up like over time. So I guess I'd love to understand from you, like, is this something that you think will continue to kind of uphold, or do you see there being some point where a sufficient quantity of the stake essentially says like, hey, actually we're like here to be kind of like ruthless, kind of like capitalists within this kind of semi, anonymous ecosystem? And they go back to that maximize free yield? Or do you think they'll be able to kind of hold this equilibrium of like everyone's going to be a good actor because that is like in everyone's interest kind of long term?
I don't know. I think like one important difference is, for sovereign L1s is the ability to socially slash validators, which you don't have to the same extent in Ethereum. I think, the roll-up version of this too, just to help like application level things recapture MEV is fork choice rules that are based on how much MEV how much MEV the chain is recapturing, right? You can create like competitive or cooperative mechanisms around there that are a lot more expressive than Ethereum has had up to this point. And, for what it's worth right now, like this is playing out real time in Cosmos. So on Osmosis, there was a lot of hand-wringing and concern around off-chain actors extracting MEV, including Skip. The core Osmosis team and the core contributors there really didn't want any kind of off-chain block building market to emerge. And there was a solution for that. I mean, Skip is obviously one of them. There's another one. And, we talked the Osmosis core team. We decided not to launch there. The other solution did launch there. And what the Osmosis team did is they, put together a proposal where they said, look, guys, like, we think this is bad for our ecosystem. We're working on other mechanisms to mitigate MEV around threshold encryption. In the meantime, like, please don't do this thing around maximum extraction. And if you do, we are going to try to police you and we will kick you out of the validator set. We can't necessarily prove 100%, but we are going to like do everything in our power, as the core developers and as the community to ensure that your behavior continues to reflect what we believe our users care about and what you believe our users care about. And what you've seen is that like that's worked so far. I mean, it's been only months. It hasn't been years, but like that has worked. Nobody is running the off-chain solution, or very, very few validators are running the off-chain solution there. So, what Skip's response to that was we worked with that team to build in protocol MEV recapture solutions, because like you can do that kind of thing when you have a rollup or an app chain. And I assume you'll see this play out again more and more. I don't know, like another thing that's cool to look at just on this point is if you go to our website, skip.money/validators, you can see who's running Skip on each of these different chains, and you can see the percentage of MEV that the validators are choosing to keep for themselves versus give back to the stakers. And it's different, like the average is different on different chains. So like Juno, for example, those validators are like very generous. They give back like on average like 80% of MEV, and that's held up even while the profit has basically 25x'd in the course of the last 6 weeks. But on Evmos, the validators give back less. They give back something like 60 or 50% on average. And so you do see like meaningful differences between communities here.
Yeah, I think kind of like a controversial point here, right? And I don't want to like derail this into like, this discussion necessarily, but something on my mind is like, I think there's an interesting distinction, I think, between kind of the scale of a chain. And what I mean by that is like, this is like a question of like app specific, where an app specific chain is kind of, it is easier to have a probably tighter knit community by way of having less scope, and therefore you don't have kind of different groups of people that all participate in something like Ethereum, right? There are very, very different groups of entities within Ethereum. There are DeFi people, there are NFT people, there are like different kind of communities within that. Whereas presumably within an app chain, it's much easier to have kind of one cohesive community that can kind of have this kind of social community policing and say like, hey, we as a community all agree to this, where past some kind of threshold of decentralization, right, you no longer have a single unified kind of like groupthink opinion that says like, hey, we all agree on this. I think from some kind of like certainly like crypto OGs, like people coming out of like a Bitcoin camp or even like a historical Ethereum camp, they might hear the idea that like, oh, the core team says they'll socially slash you if you do something that is like capable within the protocol, but like they just like kind of ideologically disagree with. Like that sounds like a very concerning kind of thing that like, you would get, ranted at by like Bitcoin maxis, and maybe not even Bitcoin maxis, just like general like Bitcoiners, right? So I think there's something interesting in that about like, app chains and kind of the idea of like sovereign MEV and how that kind of creates more cohesive communities that may have smaller scope individually, but are allowed to be more aligned kind of in their mission or their kind of opinions.
Exactly. Yeah, I was just gonna say that to me, sovereign chains is what enables sovereign MEV. Or that's my thesis. Like it's impossible. You need sort of that level of coordination and sovereignty to be able to like recapture MEV in the way that like a community wants to. Although I definitely want to hear from Elijah on this because I know that they might be able to design this actually within the application itself. I'm not sure, but maybe that's possible. You definitely can't do any social slashing, but maybe the application can have some sort of like logic that does this. But I think this is a really interesting like concept, and just on the Bitcoiner versus like OG Ethereum crowd, right? There's this idea that code is law, right? But in the modular ecosystem, at least for Celestia, we really believe that social consensus is like layer zero is social consensus, and like that is what law is, not code. And so to us, I think like the modular blockchain, one of the big selling points of modular blockchains and running your app on your own L1 or your own rollup is that you get that social consensus, you get that sovereignty back. And I think that could be a really powerful driving force for adoption of the stack. Is like, hey, why are you building on Ethereum and leaking all your value to a different layer or giving all this up when you can actually capture it yourself? Anyway, Elijah, I want to hear from you on this.
Yeah, yeah. So one of the things that first excited me a lot about Celestia and sovereignty, and I've had some some sobering realizations since that like are all addressable, and I think like are part of the desirable design decisions to like think about when designing a modular stack. But was this idea of like MEV based sequencing rules, sovereign rollups, can choose in essence what we're calling a fork choice rule for their rollup. And like in theory, this is like a really, really, really nice idea. In practice, and like just to shill, a paper that I co-authored recently, and I see Malesh is listening into this Twitter space. One thing that we actually found is that like if you formalize a lot of like if you formalize a lot of like the systems and dynamics around MEV auctions, and having a sequencing competition to return the most value back to users is in essence an auction, and there's only a single proposer, that the surplus of that auction should actually end up in the proposer's lab. Right, like the proposer should be the one that censors all of the bids that they want to, and includes only the bid that they deem right at the end of the day, and can keep all the extra value for themselves. And so this is a product like what we've discussed a little bit earlier in the spaces, which is that in leader-based consensus protocols like Tendermint, like Casper, like Snowflake, right, there's a single block proposer who has a monopoly over what's included and how what is included is ordered. And like this is, when someone has like monopoly on something and they have a financial interest to exercise it, right? The sort of accelerationist point of view is that they probably, most likely will and if they're rational, will exploit that. And so I think like the sort of interesting design space here is like there's this really positive notion of sovereignty, but sovereignty is still to some degree mitigated by the monopoly that any single given block proposer has over the system. And so, I think like, one thing that would be interesting for Celestia to think about, and that we've talked about a little bit in the past, is this idea of taking away that monopoly and creating a system where multiple block proposers actually contribute to what is included in a block and how those transactions are ordered within that block. And I think that like if that can be tackled, then you get a lot of these nice properties around what you can actually do with MEV auctions. You can imagine that if like you have multiple block proposers, and all you need is for your transaction to be included by one of those multiple block proposers for your transaction to make it into a block, you get much better guarantees over like what can and will be censored, and you can like run these auctions much more smoothly. But I think like this idea of sovereignty in general, right, and giving the power back to users, right? We talked a little bit about like where like where the power dynamics lie. Where in like Ethereum, the validators have a ton of power, whereas in like Cosmos, where we have app chains, right? The sort of power dynamic is much more that like the users and or core development team has a lot of power because they're sort of the ones driving the roadmap and or bringing in the liquidity. And so in sovereignty, a nice part is that like because it is so easy to permissionlessly fork, anyone can do it at a really low cost, right? Versus like in the chain world, right? The cost of like forking and then maintaining a decentralized validator set is like really significant. Versus in like the sovereign rollup world, right? The cost of forking and just like having like some full node that's running an alternative sequencing route is much more cheaper, or it's much cheaper, but can still retain a lot of the benefits of decentralization, inherited by this Celestia's validator set. I think that's like the exciting part about sovereignty here, right? Is that like it's shifting the power back to users and or like people that might not have like war chests full of cash and teams full of engineers to like go and decentralize a validator set. But yeah. But I also think like a lot of focus should probably be taken to the base, or the validator set and how consensus is actually working, and the logic by which like transactions will actually get included. So yeah.
Awesome. Well, so we have a few more minutes left, and I wanted to shift the topic of conversation to sort of the last thing that we haven't covered yet, which I find really exciting, which is shared sequencer networks and the role that they will play in MEV. And we're lucky because we also have Evan listening. He's one of the engineers at Celestia, and he wrote this amazing post on our forum where he kind of proposed this really cool notion of lazy rollups, where essentially you can, the standard way of doing sequencing for rollups is that you have like this tight coupling between execution and sequencing or ordering. And in his model, actually, you can have sequencing be like decoupled from execution. And it's a really interesting idea. And I know we've talked about that, but I want to go into like what is the design space for shared sequencer networks? What is the motivation? Like why would they be useful? And also touch on, hopefully we have time, cross-domain MEV. And is cross-domain MEV uniquely kind of enabled by building in a modular stack with a shared data availability layer? So big topic. Whoever wants to jump in first, go ahead.
Yeah, I guess I can jump in on this, and I think the kind of idea of the shared sequencer ties in a lot to, what Elijah mentioned about, this question of like easy forkability and, this kind of broader space of like what flexibility in design and, kind of deployment do you get in the sovereign rollup ecosystem, right? So right now, I think rollups in general are in a very nascent design space. We essentially have two that are really live. The ZK EVM people can be mad about, me saying there's only two, but like, generally, right, there's like Optimism and Arbitrum that are like live and being used on like mainnet with like actual trading happening, and both of them have centralized sequencers, right? So we don't really have a use case or like a live example of like what decentralized sequencing actually looks like across rollups right now. But the kind of proposal Astria is working on building obviously from Evan's post on the forum and discussions we've had with Evan, is this idea that like we could propose a network of sequencers that are, building on Evan's design, right? Like they're lazy. And so what we mean by that is we essentially have this kind of opaque block space market where we say, hey, you submit a transaction to us and we will order it. And then the fork choice rule that your rollup kind of agrees to is that of the shared sequencer. And the shared sequencer will not execute your transaction, but there is some deterministic translation between an ordered block for your rollup and the state root that will be generated based on like a state DB, right? There's like you take like an input function of like a state DB, a given ordered transactions, a block essentially, right? And then you get a new state root from that, right? And the idea with these kind of lazy rollups is that you can have an architecture where it's permissionless to join like a sequencer set. And this goes back to like Elijah's thing about like how much effort is it for someone to decide they want to stand up a new rollup or to fork away an existing rollup? And if you separate the sequencing component from like execution, then it allows you to have, this, sequencer layer that sits there and anyone can show up and just push transactions into it, pay whatever the kind of market price is for transaction to be included there. And they get some, decentralization guarantees for, liveness or whatever from that. And then they can run whatever kind of state machine they want on, call it like the back end that lazily evaluates these ordered blocks of transactions. And we just see it as this kind of component that makes it much easier for, people to kind of stand up a larger quantity of rollups versus what we've seen is like, quite frankly, like a relatively heavy burden within the Cosmos ecosystem of you want to launch a Cosmos chain. How do you coordinate kind of sufficient number of validators and how do you incentivize those validators to, produce blocks for your chain? Again, separating this execution and ordering allows you to at least get the ordering for relatively cheap in a way that does not constrain the design space of execution. I think there's some interesting implications just touching on like sovereign MEV. Like I want to be like upfront about, right? If the idea is that if you're rollup utilizing a shared sequencer for your ordering, MEV is extracted at like the ordering step. So you would not, using kind of Skip's terminology, have sovereign MEV. You would be participating in this kind of single MEV market across all rollups that are participating in the shared sequencer. And you'd be bidding into that kind of same market where if you want to order your transactions in a certain way, but some other rollup is also utilizing the shared sequencer and they're bidding much higher for their ordering because they have some profitable arbitrage or whatever on their chain, you are having to participate in that market. So it does kind of potentially reintroduce this kind of noisy neighbor question of like this shared block space market. But we think at least there's like potential for this to be a beneficial design so that you can have a much larger number of rollups where each one is not having to go through kind of the same, whether it's like BD or kind of, like infrastructure stage of setting up a large kind of decentralized set of sequencers, which quite frankly, we haven't even seen kind of the large, north of $1 billion TVL Ethereum rollups actually kind of pursue. So it seems like there's at least some kind of technical, if not kind of, I don't know, like coordination challenge to like actually get that set up, such that like even the live rollups right now haven't pursued it or prioritized it.
Barry or Elijah, do you guys want to?
Yeah, I mean, I think that's a great explanation of it. I think like what I would hope to see on Celestia over time is like a market of shared sequencers that rollups can opt into and opt out of, and force those shared sequencers to compete with one another for the business of the rollups that are on top of them, and through that competition create a mechanism by which rollups can sort of recapture at least some of their own MEV. It's like, okay, I'm going to give you the right to order my transactions and extract MEV from me, but like we're going to expect, we're going to have some way where we can try to have like a bounded expectation around how much MEV we think we're worth right now. And if you're not paying, our community some portion of that, we'll go and we'll find a rollup who might be. And you'd need multiple shared sequencers, shared sequencer networks for this to be the case. You need like not a single one of them to become super dominant to a point where like there are other reasons that the rollups can't opt out. And you'd need it to be designed in a way where your rollup can be quite agnostic to which shared sequencer it's using. But that's a line of thinking that I think is interesting. I mean, I think oftentimes people just like wave their hands and say like, oh, the market will solve this, but I think like that's probably like the one of the ways and a good way for shared sequencers to compete. And I hope like the Celestia ecosystem, grows big enough to support that kind of competition. I think that'll be really, really cool to see and good for end users as well.
Yeah, as a rollup builder or rollup community, using a shared sequencer is very convenient and saves you a lot of overhead and time. But then you are kind of giving up the ordering, which gives them access to MEV. And so if they have a monopoly on that, they can kind of like be more extractive. But if there's competition, there's like, hey, I can migrate. You better treat me well as your customer. Otherwise, I'm going to go somewhere else. I strongly agree with that.
Yeah, I think there's kind of two phases of this, and Elijah, I see you. I'll make like a quick point here, right? Like, obviously, like, we're building a shared sequencer network. There's this kind of competing goal of like we want to be successful and like attract users and whatnot, right? But so there's kind of two components, right? There's the architecture, and we believe that like the shared sequencer architecture we're designing works in such a way that it's relatively easy for a user to go, move over to an alternative sequencer for whatever reason they don't want to continue using this, whether they want to go to their own, sovereign sequencer, whether they want to use a competing kind of shared sequencer. The benefit of all the data is fundamentally like written to Celestia at the end of the day. We think that's a very, very good kind of like way such that we can show like, hey, you don't even have, something that's very common in kind of cloud ecosystems of like, it's expensive to egress your data to like an alternative cloud provider. So once you're kind of sufficiently far along, you're stuck there. This sequencer is very much something in kind of, liveness, right? So yes, you might have to like pause your chain if you want to switch over, and maybe it's hard to coordinate kind of a live switch, but all your data fundamentally can remain in the same place, and you can still move to kind of a new sequencer if the one you've chosen, whether that's Astria or someone else, isn't kind of satisfying to you for whatever reason.
Yeah. So maybe going back to, just stepping back 1 second. Like I think one of the things that really attracted me about Celestia initially was I think there's going to be a number of experiments around composability. Now that you have a bunch of sovereign applications that share block times, right? So we spoke a little bit about this problem earlier, where there's a bunch of chains that all have different block times, and while it's valuable to have while it's valuable to have like be a validator on multiples of these chains, whether or not those block times will sync up at certain points or not is like an open question, and how often it does for them to capture value from it is another question. There's also a lot of use in block time syncing up. That while it's easier to extract value, like there's also composability benefits. So I think like as a whole, having shared block times by sharing a DA layer is something that like I think is going to be it's going to be exciting to watch the experiments that play out there. I think like the decentralized sequencer I'm most excited about, other than Astria. I think Josh is probably one of the top thinkers about how sequencing in the modular stack as a whole should work. But another decentralized sequencer that I'm really excited about is actually Celestia as a decentralized sequencer. And I think like this was sort of this idea of like MEV-based fork choice rules or MEV-based sequencing rules native to Celestia. I think it'd be really, really cool if Celestia and other like modular layers could crack the censorship problem. This sort of like monopoly that any given leader and leader-based consensus protocol has over what actually gets included in the block. Crack that problem and make it such that you can have like a bunch of different people who are all competing to get included into a Celestia block and get their blocks their inclusion in Celestia block is like a block for a rollup, right? It's a set of transactions that will be executed by some rollup. And you get a bunch of these different blocks formed and included in Celestia block without the risk of censorship. And then you can have the rollup, based on rules that are just ingrained into the actual rollup itself, decide which one of those blocks is the canonical one. I think like that's in a lot of ways almost like the holy grail of decentralized sequencing, where you don't need to touch anything else. You don't need to bootstrap a new validator set. You don't need to do anything else. You just have it like out of the box in the actual DA layer itself. I don't think it's an easy thing to accomplish. I think it's a really, really great goal to strive for. And I think like in any decentralized system, there's going to be imperfections, but I think like there are ways to smooth a lot of the surface there. And some of the ways I talked about earlier was creating systems which have multiple block proposers is one of those ways. And so, yeah, so I think that's like something that'll be really, really interesting. And, it's sort of like Celestia itself being a shared sequencer, Celestia itself being the sequencer, I think is like a really exciting point. That has to do with like, all these rollups settling on the same DA, or not settling on the same DA layer, but posting, blocks to the same DA layer and sharing block times, right? So they're sharing block times. They could share the sequencer as the actual DA layer. I think it's a pretty exciting idea. But, we've got our ways to go.
I love that. I mean, the original Lazy Ledger white paper, I mean, that's what it was, a lazy ledger and client-side smart contract. So the original vision was kind of that, it was kind of pre-rollups. And the idea was people just post data, like end users interact directly with the data availability layer. But then with the whole idea of rollups emerging, it kind of became this thing where, we expect there to be this other layer that users interface with, and then like the rollup sequencers interface with Celestia. But there's actually nothing stopping someone from using Celestia in that way. So yeah, it'd be interesting to see how that all plays out. Well, we're at time, so I want to open it up for you guys just to give any closing remarks and also share where people can learn more about your projects and what you're building.
Yeah. So quickly, closing remarks. Super fun conversation. Nick, thank you for your time. Elijah, Josh, thank you for all the insightful comments. Whenever I talk to you guys, I feel like I learned so much about the modular stack. But just in terms of MEV, I think I just want to echo Elijah's point that like one thing that's been really great about operating in Cosmos is that having the Cosmos SDK and Tendermint as building blocks that people can use has led to larger scale, faster experimentation than you're able to see in other ecosystems, across the block building and transaction designing design space. And I think like with the modular stack, you're going to be able to see a lot more of that with MEV itself directly. And we're super excited to be a part of that future. You can see more about Skip at skip.money, and you can look at our open jobs at jobs.skip.money.
Anything else? I'll give similar closing remarks. So, like, once again, like, yeah, echoing Barry's point, right? Always good to talk to Barry, Elijah, and Nick, you as well, on, all things modular, or, MEV specifically. For us, kind of on like where you can find us, we're pretty early here from like a publicity perspective. We're kind of in stealth, but, you can kind of follow the Astria org Twitter account. ASTRIAORG, or just kind of myself on Twitter if you're looking for updates, and we're hoping to have kind of more public information kind of in the coming weeks here.
Yeah, thanks for having me as well. I mean, like I'm really, really excited about what Celestia is doing, what modular crypto will look like as a whole. The way I've sort of like formulated it in my mind is that every cycle there's some new asset class or some new reason to come on chain, and every time our systems fail the users, and they fail the users because transaction fees are high, and they fail the users because the users are being extracted value from, right? And so that's the question of MEV, and that's the question of scaling. And I think that like this is an incredibly interesting talk because it's sort of the intersection of the two. It's like, how can we solve like the two biggest problems towards actually building decentralized systems that users can touch and feel the benefit of without needing to worry about like losing value or paying ridiculous amounts. And so the way I've been saying it to internally to friends and to to people I work with is I really see this as like sort of the GPU moment for crypto, where like things become cheap, fast, flexible, can handle tons of data, and can do it around the world. So I think it's really exciting. And yeah, you can find Duality. We have a website, duality.xyz. You can follow us on Twitter. Just to sum up again, we focus on like MEV solutions for decentralized exchanges, and we're building a decentralized exchange, which, recaptures MEV and returns it back to the LPs, because we sort of see that as like an existential problem towards, liquidity provisioning being like a viable thing to do on chain. And yeah, thanks for having me.
Fantastic. So thanks everyone for coming. Thanks for listening. If anyone's out there interested in these topics, get in touch with us. There's tons to build, as you can tell, and the modular ecosystem is a rapidly evolving and growing space. and there's no shortage of things to get involved in. So if you're passionate about this, like, get in touch. Seriously, we'd love to hear from you. And once again, thank you to the speakers, Elijah, Josh, and Barry. A lot of exciting stuff to come from these projects. And let's keep the conversation going on Twitter. So if you guys have any more questions or thoughts, or this, like, any of the discussion, gave you some ideas, post them on Twitter or on our forum, and let's continue the conversation. There's still a lot to explore. Thank you, guys. We'll see you next time.